This is SpaceTime Series 26, Episode 42. Coming up on SpaceTime, RNA nucleobases found in space rocks, discovery of an asteroid orbiting the Sun inside the orbit of Venus, and scientists have concluded Oumuamua's weird trajectory out of our solar system might have been due to gas. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists studying samples of the asteroid Ryugu, brought back to Earth by Japan's Hayabusa 2 mission, have discovered that it contains uracil, one of the 4 nucleobases that make up RNA. It's an important ingredient in some forms of life. RNA is a single-stranded molecule which has short chains of nucleotides. It works in a similar way to DNA, which is a double-stranded molecule with longer chains of nucleotides. DNA can reproduce itself through self-replication. RNA doesn't replicate on its own. As well as uracil, the authors also found niacin, a form of vitamin B3 which plays an important role in metabolism. And they found amino acids, amines and carboxylic acids, which are found in proteins and metabolism. This discovery adds to a growing body of evidence that the building blocks of life exist in space and may have been delivered to Earth in the form of asteroid impacts. In a way, this discovery is nothing new. Scientists have previously found nucleobases and vitamins in carbon-rich meteorites. But those meteorites had already made contact with the ground, and that raised the possibility of some form of contamination. However, the Hayabusa 2 samples from Ryugu are pristine. They were delivered in sealed capsules, thereby ruling out any risk of contamination. The uracil and niacin were detected by scientists examining 2 samples from the asteroid taken from different locations. The samples were first soaked in hot water. They were then subjected to high-performance liquid chromatography coupled with electrospray ionization high-resolution mass spectrometry. The same technique was employed on the famous Murchison meteorite, which fell to Earth in rural Victoria near the town of Murchison in 1969, yielding 5 different nucleobases. Now, the range of biomolecules found in Ryugu was smaller, but still significant, with between 6 and 32 parts per billion for uracil and 49 to 99 parts per billion for vitamin B3. Scientists believe that compounds containing nitrogen may have formed from simpler molecules including formaldehyde, ammonia, and hydrogen cyanide. Now, these have not been found in the Ryugu samples, but they were likely present if, early in its history, the asteroid or its parent body had been a comet coated with ices rich in these molecules. Ryugu, however, is just the beginning. NASA's collected a sample from another asteroid, Bennu, and that'll arrive back on Earth in September. We'll keep you informed. Meanwhile, meteorites from a small metre-wide asteroid, which lit up the night skies when it airburst over the English Channel back in February, have been discovered by meteor trackers in France. The asteroid, 2023 CX-1, entered Earth's atmosphere around 3 a.m. on February the 13th and was visible across southern England, Wales, and as far south as Paris. The discovery is significant because this asteroid was actually identified 7 hours before reaching the Earth, thereby allowing astronomers to trace back its path through space. And the meteorite sample was found just 4 hours after the asteroid entered the atmosphere. This is SpaceTime. Still to come, the discovery of an asteroid orbiting the Sun inside the orbit of Venus. And could gas be the reason for Oumuamua's weird departure from our solar system? All that and more still to come on SpaceTime. Astronomers say the discovery of an asteroid orbiting the Sun inside the orbit of Venus could be the first of a population of previously unidentified inner solar system asteroids. The 2-kilometre-wide reddish-coloured asteroid's discovery by the Palomar Observatory in Southern California has been reported in the monthly notices of the Royal Astronomical Society. Most asteroids orbit the Sun at distances further out than the Earth, with the majority in the main asteroid belt between Mars and Jupiter. Those orbiting inside of Earth's orbit around the Sun are mostly members of the Apollo group of asteroids. The editor of Australian Sky and Telescope magazine, Jonathan Alley, says this new discovery could be the first of a new population.
Most people have heard of the asteroid belt, right? The main asteroid belt, which was the only asteroids known for many, many years. The asteroid belt is about halfway between Mars and Jupiter, so it's a fair way out. And there are thousands of asteroids circling the sun in roughly similar orbits at that distance. And look, it's not like you see it in the movies, you know, that sort of scene in Star Wars or those sort of ones where they're dodging and weaving around asteroids and things. That's not what it's like. You know, the average distance between asteroids out there, I think, is approximately 1 million kilometres. So it's a lot of empty space, a lot of asteroids. But anyway, look, other asteroids have been found in different sort of orbits, and it's just families of asteroids, Apollos and others, have been found in different sorts of orbits that are not in the main asteroid belt. They've discovered one that's orbiting the sun within the orbit of Venus, so closer to the sun than Venus is, which is quite unusual because it's not really a stable sort of place for asteroids to live because there are lots of gravitational effects closer to the sun. So it's a bit unusual to find it there, but they spotted one anyway, first time. And where there's one, there might very well be more, of course, because, you know, what are the chances of just spotting the only one that's there? Now, the interesting thing is that they don't know a lot about it, but they can sort of analyze the color of it and the sort of chemical composition just based on the light spectrum from it. And it does seem to be basically the same as a main asteroid belt asteroid. So it's likely to be a main asteroid belt asteroid that got flung out of the main belt somehow or other at some time in the past, and it's ended up in this orbit closer to the sun. And they think that its present orbit is not stable. It's very likely that it's probably going to crash into Venus sometime in the next 10 million years or so, which sounds like a long time, but it's not really a long time in the big scheme of things of space. And it's got an interesting name. I'll try and get this pronunciation right. Alocheknim, I think it is. Forgive me, those people who know this particular indigenous North American language from California, but it's not one I'm familiar with. But the name means Venus girl, I think, Venus girl, which sort of makes a bit of sense because it's not too far from the orbit of the planet Venus.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is Space Time. Still to come, scientists come up with a surprisingly simple explanation for the alien comet Oumuamua, which appeared to accelerate as it left our solar system. And later in the science report, a new study shows that some salads really do scream when you eat them. All that and more still to come on Space Time. Scientists have developed a surprisingly simple explanation for the interstellar comet Oumuamua's weird orbit, which appeared to accelerate as it left our solar system. A report in the journal Nature has concluded that the comet's sudden burst of acceleration might have been caused by hydrogen outgassing. Back on the 19th of October 2017 on the island of Maui, astronomers using the Pan-STARRS-1 telescope, operated by the University of Hawaii, first noticed what they thought was either a comet or an asteroid. As they gathered more and more information, they discovered that its tilted orbit and its high speed, some 87 kilometers per second, implied that this wasn't an object from our own solar system, but something that came from interstellar space. The object was then named Oumuamua, Hawaiian for a messenger from afar travelling fast. But it was strange. It had no bright coma or dusty tail like most comets do, and it also had a really weird shape. Something that looked sort of halfway between a cigar and a pancake, you know, like a flying saucer. But most intriguing of all was the fact that it was seen accelerating away from the sun in a way astronomers simply could not explain. And of course that led all the usual pundits to claim it must be an alien spacecraft. Aside from dust grains, this was the first interstellar object ever observed in our solar system. A second object, Tuai Borisov, was discovered in 2019, although it looked and behaved more like a typical comet. As more and more telescopes focused on Oumuamua, astronomers were able to chart its orbit with greater detail, eventually determining that it had already looped around the Sun and was now headed back out of the solar system. Now, a new hypothesis suggests the comet's mysterious deviations from its hyperbolic path around the Sun could best be explained by a very simple physical mechanism, which is likely common among many icy comets, namely the outgassing of hydrogen caused by the comet being warmed up by sunlight. To date, all comets observed in our solar system, both the short-period comets originating from the Kuiper Belt and the longer-period comets from the more distant Oort cloud, have ranged from around 1 kilometre to hundreds of kilometres across. What made Oumuamua different from every other well-studied comet in our solar system was its size. This reddish-coloured comet is only roughly 115 by 111 by 19 metres in size. It was so small that its gravitational deflection around the Sun was highly altered by just a tiny push created when hydrogen gas spurted out of the ice. Comets are icy rocks left behind from the formation of the solar system 4.6 billion years ago. See, most comets are essentially dirty giant snowballs that periodically approach the Sun from the outer reaches of the solar system. And so by studying them, scientists can learn a lot about the conditions that existed when our solar system was being formed. And just like our solar system, other stellar systems are likely to eject comets from time to time because of gravitational interactions with other objects in the system, such as other planets or simply approaching the Sun from the wrong direction and being flung out into interplanetary space. These are what are known as rogue comets, and occasionally they're expected to enter our solar system, providing an opportunity for scientists to learn about planetary formation in other star systems. When comets approach the Sun, the water and gases ejected from the surface create glowing gaseous comas and release dust in the process. Now, typically the dust left in the comet's wake becomes visible as one tail, while vapor and dust pushed by light pressure from the Sun's rays produce a second tail pointing away from the Sun, very much like an inertial push outwards. Other compounds, such as entrapped organic materials and carbon monoxide, can also be released. The ejected gases do act like thrusters on a spacecraft, giving a comet a tiny kick that alters its trajectory slightly from the elliptical orbit typical of other solar system objects like asteroids and planets. But with Oumuamua, astronomers could detect no coma, no outgassing molecules, and no tail, and was too small and too far from the Sun to capture enough energy to eject a lot of water. And that led astronomers to speculate about its composition and what was pushing it outwards. Was it a hydrogen iceberg outgassing, a large fluffy snowflake pushed by light pressure from the Sun, or maybe a light sail or spaceship created by some sort of alien civilization? Astrochemist Assistant Professor Jennifer Bergner from the University of California, Berkeley, who studies chemical reactions that occur on icy rocks in the cold vacuum of space, thought there might be a simpler explanation. She broached the subject with astronomer Darryl Seligman from Cornell University, and they decided to work on the project together. Bergner says that a comet traveling through the interstellar medium would basically be getting cooked by cosmic radiation, in the process forming hydrogen. Now, if this was happening, and the hydrogen was trapped in voids inside the comet, then when it entered the solar system and was warmed up by the Sun, it would start to outgas some of that hydrogen. So the next question is whether or not the amount of hydrogen produced would be enough to explain the non-gravitational acceleration seen on Oumuamua. Surprisingly, she found that experimental research published in the 1970s, 80s and 90s had already demonstrated that when ice is hit by high-energy particles akin to cosmic rays, molecular hydrogen is abundantly produced and trapped within the ice. In fact, it turns out cosmic rays can penetrate tens of meters into the ice, converting a quarter or more of the water there into hydrogen gas. Now, for a comet several kilometers across, all this outgassing would form a really thin shell relative to the bulk of the object. So, both compositionally and in terms of any acceleration, you wouldn't necessarily expect that to have a detectable effect. But because Oumuamua is so small, astronomers think that it actually produced sufficient force to power the acceleration that was seen. While the relative proportions were fairly certain, astronomers couldn't be sure of the actual size because it's too small and too distant for telescopes to resolve. The size, therefore, had to be estimated from the comet's brightness and how that brightness changed as the comet tumbled through space. Because Oumuamua's brightness changed periodically by a factor of 12 and varied asymmetrically, it was assumed to be highly elongated and tumbling end over end. Astronomers also noticed something strange, a sudden slight acceleration as it moved away from the Sun. This wasn't being caused by any sort of gravitational slingshot effect, but was something quite different. In addition, calculations showed that the solar energy hitting the comet wouldn't be sufficient to sublimate water organic compounds from its surface in order to give it anything like the non-gravitational kick that was observed. Only hypervolatile gases, such as molecular hydrogen, nitrogen, or carbon monoxide, could provide enough acceleration to match the observations which astronomers had seen. And this led to much speculation about what volatile molecules were contained within the comet in order to cause its acceleration. Now, Sleekman had earlier published a paper arguing that the comet was composed of solid hydrogen, a hydrogen iceberg if you will, and it would be outgassing enough hydrogen in the heat of the sun to explain the strange acceleration. Under the right conditions, a comet composed of solid nitrogen or solid carbon monoxide would also outgas enough force to affect the comet's orbit. But astronomers still had a stretch to explain exactly what sort of conditions could lead to the formation of solid bodies of hydrogen or nitrogen, which have never been observed before. And for that matter, how could a solid, say, molecular hydrogen body survive for maybe 100 million years or more in interstellar space? Bergner thought that outgassing of hydrogen trapped in ice might be sufficient to accelerate Oumuamua. And she found numerous previous experiments demonstrating that high-energy electrons, protons, and heavier atoms could convert water ice into molecular hydrogen, and that the fluffy snowball structure of a comet could entrap the gas in bubbles within the ice. Experiments also showed that when warmed, as by the heat of the sun, the ice anneals, changing from an amorphous to a crystal structure, and that forces the bubbles out, releasing the hydrogen gas. Bergner and Seligman calculated that ice at the surface of the comet could end up emitting enough gas, either in a collimated beam or a fan-shaped spray, to affect the orbit of a small comet just like Oumuamua. This is Space-Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has warned that most of Australia's reef species have declined in population over the past decade. The findings, reported in the journal Nature, show that the majority of species living in Australia's shallow reefs experienced a population decline between 2008 and 2021. Scientists combined results from 3 of the world's longest-running reef monitoring programs in order to estimate population changes among more than 1,000 species across 1,600 sites around Australia. They found that while coral populations remained relatively stable, tropical fishes, seaweeds, and invertebrates such as starfish and sea urchins were among those which saw massive declines. The authors say much of these population declines tended to follow marine heat waves, which are caused by global warming. A new study has found that our modern-day grape varieties actually originated in Israel and the Caucasus some 11,000 years ago. The findings, reported in the journal Science, suggest that the harsh climate during the Pleistocene era resulted in the fragmentation of wild ecotypes, and that paved the way for the domestication of modern-day grapevines. Scientists reached their conclusions after sequencing the genomes of some 3,525 grapevine varieties, including 2,503 domesticated grapes and 1,022 wild varieties, in order to identify the genetic changes that occurred during the domestication and evolution of grapevines in the Euro-Asian region. The authors found that the Near Eastern Israeli grapevine population is the source for the domestication of table grapes, which then dispersed into Europe with early farmers, which they then crossed with local ancient wild Western varieties, and then diversified into unique Western wine grape ancestries by the late Neolithic. Remember the old anti-vegan joke about salad screaming when you prepared it? Well, it turns out that some plants really do let out sounds when they're stressed. A report in the journal Cell claims tomato and tobacco plants really do let out sounds when they're dehydrated or have their stems cut. A study by scientists at Tel Aviv University found the frequency of these sounds is too high for humans to hear, but could probably be heard by insects, other mammals, and maybe even other plants. The researchers used microphones to record healthy and stressed tomato and tobacco plants, and then trained machine learning algorithms to differentiate between unstressed plants, plants which were thirsty, and cut plants. The authors found that the stressed plants emitted more sounds than the unstressed plants. The plant sounds resemble pops or clicks. No word on exactly how they're made. But a single stressed plant emits around 30 to 50 of these clicks or pops every hour at seemingly random intervals. There have been countless studies trying to determine if ghosts are real. Most, of course, are shonky. But for those who are genuinely trying to study the phenomenon of ghosts using the scientific method, if you start on the assumption that they could really exist, the first hurdle would be determining exactly what a ghost actually is. See, the problem is, different cultures have different beliefs and ideas about what ghosts are and how they appear. So consequently, the commonly held beliefs about the behaviours of ghosts and their appearance can vary widely from one country to another. Tim Mendham from Australian Skeptics says the lack of reliable repeatability and the variability of experiences suggest that there may be many different factors that play a role in determining the nature of ghostly activity, including individual perceptions and experiences, cultural beliefs, and the physical environmental conditions in which the activity is alleged to have occurred.
It's really sort of trying to get some sort of description of them, of the circumstances, and sort of an explanation of the nature of ghosts. And obviously there's a lot of issues about what form ghosts take. There's a recent article came out on what is a popular website called Higgypop, quite good articles there, that tries to find some 8 common beliefs and features of ghosts. And the trouble is a lot of them have inconsistencies. So obviously one problem with ghost hunting being a scientific endeavour, and I'm sure a lot of ghost hunters would think that they were doing something scientific, is that it's not repeatable. Okay, it's very hard to go there and always get the ghost there, always at the same time, and to sort of study it. There's other things that some people see ghosts, other people don't. Do ghosts have a physical form? If they don't have a physical form, how do they knock things over? How can you see a shadow? If they can walk through walls, etc., how come they don't fall through the floor? All sorts of issues. And
I think they're all very good questions, actually.
These are very good questions. It's a website called Higgypop, which is a popular site, popular culture site, often about the supernatural and the paranormal, has some very, very good articles. So it's Higgypop, Higgy. And the fellow who writes it is actually quite sensible, very quotable, because there's other issues as well that he doesn't count. One is the actual existence of do ghosts exist, and he sort of obviously questions a lot of these things and goes through all these various criteria and said, this could mean, or this could also mean, right? It could mean some people are sensitive to ghosts and others don't. It could mean that some people are just oversensitive and will see anything as a ghost. All those sort of questions he raises and very worthwhile asking. The other issues is, what are ghosts? Are they the form that you died in? Are they a spirit? Are they an orb? Are they troubled people who have died in terrible circumstances and trying to find their way somewhere? Are they people who are happy where they are and just sort of appearing and saying hi? Are they nasty? Are they friendly? Do they try and scare you? Do they try and comfort you? And of course, how many are there? And you do a quick sort of search of the net and you find out that there's probably about, for every person who's alive now, roughly, no one's quite sure, but roughly, there's 13 people who have died. So 8 billion people
come. You're forgetting the pets, all the puppy dogs and pussycats as well.
I'm completely forgetting the pets and the puppy dogs, which apparently have their own ghosts as well, which makes it even worse. But if there's 8 billion people alive, then there's about 109 billion who have died, and that makes 117 billion total. So how come there aren't ghosts everywhere? Right, for every one person on Earth, there's supposed to be 13 ghosts. We could be crowded with ghosts. We go to a place with a heavy sort of concentration of people like a big city. You surely couldn't move for ghosts, but they only tend up to appear in pubs and knock over glasses of beer, or they appear in empty buildings or churches, etc., where they should be everywhere.
Well, if it's that crowded, you'd look for an empty space too, wouldn't you?
Yeah. But I know, but they're not always crowded. They're not always sort of in places where people don't go, and that's the whole thing. There's a whole lot of problems with trying to see this topic as a justifiable topic for study or for scientific study. You've got to get over these inconsistencies first and find some theory, and it's virtually impossible, apart from the fact that the evidence presented for ghosts is pretty slim.
It's a really great way, but of raising the issue and just discussing the inconsistencies associated with it all.
That's right, and these are things that people don't like to discuss, honestly. They just say, there's a ghost here, and it's either a face, or it's a form, or something that's moving, or something that's not moving, or it's a little kid, or it's an older person. Yeah, it's someone who dies in a car crash going to come back looking hideously damaged, or are they going to look like how they used to look and how you remember them looking like, etc. All sorts of things. Are they old? Are they getting older? Are they decaying?
Are they naked?
Do clothes have ghosts as well?
Exactly.
Yeah. And then you add, as you say, all the pets and animals, presumably. Are there ghost cows around, or ghost pigs, or ghost quokkas, or ghost sort of bacteria? Does every life form have ghosts? I know it gets a bit silly, doesn't it? But I mean, and these are all the issues with you just put up against people who proclaim ghosts and things, and they cannot answer them. They only say, well, yeah, I saw one here. And then they say, well, let's go back and see if we can all see it. And of course, if you don't, they say, well, you're not sensitive. I am. Blah blah blah. It's very unscientific. And before you can even go into the issue of studying ghosts, you've got to deal with these inconsistencies, and that's almost insurmountable from my point of view.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.